Pertaining to issues about confidence interval of this kind, so I think this is the class we'll probably draw the curtain, at least for now. Alright, in today's class we'll be looking at sorry. Welcome back to Economics YouTube channel, and I hope you're fine. Okay. Okay. So today we'll be looking at confidence interval with an unknown population standard deviation. Okay. So and I think I've been mentioning that this is actually the real deal, like for real. Because you are trying to look for like two things now. We're trying to like make an estimation for what the population mean value is going to be. And then of course we don't know the population mean, so how are we supposed to know the population standard deviation? Yeah, right. So like that is what's like the most realistic in what we've been the things that we've been building, up to this extent. So now whenever we don't have the standard deviation. So the way to get our confidence interval is to use our T table. Like I said, our T table. So because here we are not working with the standard normal curve anymore, and to be working with something that we call the studentized normal curve, like the student's normal curve. The first time I came across that, I thought maybe the textbook was playing a prank on me because I was like, studentized normal curve. Like, what was that supposed to mean? Like, is this a joke or something? But I started to research more about it, and I was like, oh wow, this is this is a real deal. I just thought like students, why do you put student? Maybe like there should be a teacherized standard deviation or teacherized normal curve. Okay, so how does the studentized normal curve look? It's also called the T curve. Like instead of the normal curve that we have normally, like the standard normal curve, so it's called the T curve, right? So the one of its properties is that it has more spread than the standard normal. It has every other properties of the standard normal curve, but just few differences. So number one, it has more spread, and more spread is talking about standard deviation. That is, it has more standard deviation than the standard normal curve. So let's say that where's my second marker? So let's say this were the standard normal curve, right? So this would be the studentized I've drawn a beautiful nonsense. So this would I don't know why do I keep doing this tail like this. It's actually like this. As if it's going to touch this axis, but it's never going to touch it. I know. Alright. So you have yeah, something like that. Something like that anyway. The same mean, but then more standard deviation. So remember when I was teaching this thing, then I said the more the standard deviation, the flatter the curve. Then it's that. So like basically speaking, you just have your T curve being flatter than your normal curve. So this would be the standard normal curve, standard NC. That's okay. Then this is the T curve. No? This is the T curve. So what are the properties of the T curve? No, they both have their meaning. It has more spread than the standardized normal curve one. The total area under it is one, just the same thing that we had under standard normal curve. Then it extends indefinitely in both directions, spreading in both directions, but never touches the horizontal axis. Same thing as the normal curve. And it is symmetric about zero. This mean now because we are turning it to this is so this guy now is zero. But let me just oh shit. Now remember that for our standard normal curve to the values are like 0, 1, 2, 3, 0 minus 1, 0 minus 1, then okay, then minus 3. So like what we have there is 0. Alright, because it's not just a normal distribution, it's not just a coefficient in a normal distribution again, like we've converted it, you know. Okay. So next is I think symmetrical. From the very first class on normal distribution, I explained what symmetrical means. So the next is as the degree of freedom increases, the T curve looks like the standard normal curve. Now there's something called the degree of freedom, which is particular to the T curve. So like if you look at this, this is a T table. I'm going to erase this guy now. This is a T table. I drew one for a Z score table too then, right? So this is a T table. Like these are things that you're going to be having there. First and foremost, the T table, the values in the T table, they are to the right of the T curve. You know, the one we do for this course represents area to the left of the standard normal table. But here, the values represent the areas like the right of the T curve. So that's one thing that we should also note. Then we have this T.50, T.75. All of those is what do they mean? And I've written the confidence level here. So T.50, now this is 50%. 0.5 multiplied by 100, that's 50%. Um, and then no, I mean this the 0.5 here. When you multiply by 100, that's 50%. The 0.5 that we have here, multiply by 100, that's 50 for one tail. That's 50%. 50% plus 0%, that gives like the 0.5 that's under this T. Now 0.25 here represents 25%. 25% plus 50%, that's 75%, Abi. So 75% is giving you T.75. Do you understand? Then 0.2, that's 20%. 20% plus 60%, that's 80%. So 80% then 0.8, like on and on, like that. Then for one tail, okay, 0.5 here is saying that you are going to be having 0.5 multiplied by what do you call it now? That means this area, this is your T curve. So let's kind of draw T curve alone. So we are trying to say that for one tail, this area represents 0.5, which is 50%. And then this area represents 0.5 as well, which is also 50%. So if this small, yeah, something like this, that means all of this space is zero. Of course, the line is not going to be like this anyway, but just telling that your confidence level is zero. If the tail, the extremes, have already taken all of the 100%, so that means your confidence level is zero. There's nothing for you again. Then what was I trying to explain again? Then for one tail, so one tail you have 0.25, which is 25%. For one, let me, okay, so 25% here. Of course, 25% times 2 will give you this 50%. So one tail is a tail is 25%. Then if you bring in the two tails, it's also 25%. 25% plus 25%, that's 50%. So which is telling us that our confidence um level here is talking about 50% now. Do you understand? Like the area here is now representing 50% of the whole total area. Okay, which is telling us what is going to what's where our estimated where our estimated parameter is going to lie, like 50% of the entire region. Now the same thing on and on. So by the time you get to 0.05, so the 0.05 is the one that we are used to. So 0.05, that's saying you have 5% on 0.1 times 100, 1, 2. Yeah, you have 5% here as well. So it's saying that your confidence interval now is talking about 90%. The parameter that you're looking for, the estimated parameter is going to be around 90% of the whole thing. So your confidence um level is 90%. So you see the way the whole thing works. So there's a relationship among all of those things. So that's being said, so we now begin to like the degree of freedom. How do we apply the degree of? No, before we get to that, let's just do. When we look for the confidence interval with a known standard deviation, remember that our confidence interval range from bar x, right? Bar x. No, I intend to use this. Bar x minus the z-score alpha over 2, then the sample standard deviation, then 2 bar x plus z score alpha over 2 and the sample standard deviation, right? So where the sample standard deviation was the population standard deviation divided by the root of the number of observations. But now that we don't have the standard deviation of the population, we don't have this person now, right? So the formula changes. So confidence interval using the t table now is going to be bar x, then minus, so this is t table t alpha over 2, then it is still the standard deviation of the sample, 2 bar x, plus then t alpha over 2 and this guy. So the difference here now is that our sample standard deviation is now equals to um, So we have S, our sample standard deviation of the mean. Okay, so we have S over root n. I don't know what have I been calling this guy since. Over root n. Okay, so here what we have now is the sample standard deviation. I don't know. I think in other classes I call this guy sample standard deviation, something like that. So now we have this S is talking about a sample standard deviation now because we have the population standard deviation. We are trying to look for a standard deviation of the mean. Okay, by X is mean, standard deviation of mean standard deviation, something like that. Now divided by the root of the number of observations. And I just hope you guys forgive me, right? Okay. But then nothing spoil. So that's the only different thing. So which means that if we are given a particular data set, we will, because what we are going to be given is going to be a sample, no matter how large it is, we would have to go and solve out the sample standard deviation on our own first before we then, so instead of the assumed value that the population standard deviation is 12.1 years, we are going to be the ones to go and solve out our sample standard deviation, and then use it, apply it in the question. Okay, then what something else is that in trying to look for our t value, yeah, the t, I think t's value, or t, or what is it even called? In trying to look for this value here, we are also going to make use of our degree of freedom. I already wrote it off. I wrote something about degree of freedom down there. I already wrote it off. Degree of freedom. Degree of freedom is given as n minus one, number of observations, then minus one. Okay, so that's how you find degree of. So whenever we are trying to use the t table, we are going to look for t corresponding to a particular area of alpha over 2 under the degree of freedom of n minus 1. Okay, so let's just look at a particular example. For a t curve with 13 degrees of freedom, determine t equals 0.05. Now another way this question might come is one of it might just be what is the number of observation. Okay, I mean, first you should determine number of observation because you know that degree of freedom is n minus 1. And then you've been given degree of freedom to be 13. So 13 plus 1 will then give you number of observation, which is 14. So n would have been 14. Very simple question. Okay, so now we have to work with this. We have to find a t curve with 13 degrees of freedom. We should determine t 0.05. We have to determine the t value that is corresponding to this particular area. Ordinarily, when I say 0.05, I know that it's falls under 90% confidence level. Okay, 90%. Because 0.05 for this deal, that's 5%. So this other side is going to be having 5%. 5 plus 5, that will be 10%. We are left with 90. So that's a way to look for it. That's one way to look for it. So I'll just have to go to degree of freedom of 13. This is 13. Degree of freedom of 13. 13 here. And I'd have to be looking for where does it correspond with the 90%. So here. So this is where they meet. So there's going to be a number here. By the time you check your T table, okay, if you're having 1 point, the number that intersects the two of them is 1.771. I've told you that the area represented by the T curve is to the right, 1.771. Okay, so that's it. So another way to just see it is since I'm considering one tail, okay, T 0.05, when you have 0.05 here, and then you drag this guy to degree of freedom of 13, and then it's still up at the same number, 1.771. So that I think that settles that. So what we now go to is how to find our confidence interval. Now that we've known like the basic things, so we are just going to cover one example, and then I think that should be all. So here we have it. Given a simple random sample data below on losses incurred due to robbery incidents, the values are given in thousands of naira. So find the 95% confidence interval for the mean loss of all robbery offenses. So we are given this. So like there are three assumptions, three things that you must consider before we begin to like apply the T table. Number one, is it a simple random sample? That has to be a simple random sample. Number two, is it a normal does it have normal probability distribution? If it does not have a normal probability distribution, is it a large data? It's like it's just two. So you should have a normal probability distribution. Okay, and then a small data. But then if it doesn't have a normal probability distribution, does it have a large data? Like, do you understand? Then the third is you don't know the standard deviation. It's like once those three criteria are met, then we move. But like for me to know if it has a normal probability, if it has a normal this thing, I would have to like maybe put the whole figures inside a statistical software, plot my normal plots. Do you remember that normal plots that we did that time? That was going to show you normality in terms of linearity. So all of your lines are they linear? Okay, all of your points when you put a line through them, like are they clustered around a straight line? Okay, or we use our histogram or whatever. But now the assumption here is that this is normal. Okay, it's normally distributed. And I think I gave one assignment in one video like that. That okay, when you have a data set, you pick the data set and then you wanted to work on it. What was the first thing that you look out for? Test for normality. Yeah, test for normality. Check if your data is normally distributed. And why are we doing that? We are trying to have a result that is representative of the population, a result that's representative. You don't want to get a mean value, for example, that is far, apart from what the population mean is. Do you understand? We don't have a sample that when we are using it to make predictions, when we are using it to explain, all we are explaining is so different from what is happening outside of the world, outside there. I think something like that's happening in Nigeria anyway. They tell us that our inflation rate is this, and then with people's what do you call it now? The people's experiences in the market on a daily basis, they know that it's grossly what is happening in the economy is grossly underreported by the NBS or something else. Stuff like that happen, sha. Okay, so how do we go about this? Now remember, what are our tools? What we basically want to do is standard. We are trying to get to this T alpha over 2, then S over root n, then 2 by x plus T alpha over 2, the sample standard deviation over root n. That's what I want to do. So, which means that our mean, add up everything, then divide it by 25. There are 25 of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, n is 25. N is 25. So, automatically, degree of freedom is 24. Okay, then by x, I can't solve that in there here. So just do the addition, do the whole thing, and then you should get 513.32. So by x, 513.32. Now the headache here is that apart from getting your by x, you would also go and look for your standard deviation by yourself. Your standard deviation is looking at t table. We use it when we now have a population standard deviation. So we are using the sample standard deviation, this s. And the formula for that s is summation of roots. Oh, what am I even writing? Root sum of f x minus bar x squared, because we are working with sample, so it's going to be over n minus 1. If we're working with the population, it would have been over capital letter N, then it stands over n minus 1. So more or less like over the degree of freedom. Okay, so this is the formula we are going to apply. And for you to be attending this class, you already should know how to calculate standard deviation. So when you do everything, your standard deviation will be getting standard deviation of what is it called? 26 points. Is it? I think is it 262? I'm seeing here. Standard deviation 262.23. 262.23. So that's our standard deviation. I think we have everything. So alpha, since this is talking about how many, this is 95%. So alpha, I'm doing this alpha over 2. Alpha on its own is 100% minus 95%, which is 5%. So alpha over 2 is 2.5%, is equal to 0.025 times 1, 2, okay, times 100, 0.025. So we have to just go and look for the t value that I think that's what we did the other time. a t value corresponding to 0.025, 2.5% times this is actually 95 here. It's meant to be 95%. So I just trace out 95% and join it with degree of freedom of 24. The other way I could do it, you have for one tail 0. So t value of 0.025 is here. So I can just bring it, I can bring this one down. Just bring this one down here. Oh, that's slanted. I was like this, just trace it up like this. Okay, so either ways, I'm going to have a value over there, and then that value is equal because I've already solved the whole thing. So it's just for me to like let you see what is really happening. So the value A is 2.064. That's the value there, 2.064. Okay, so I guess I can just rub off the question. Okay, so we have to just find 95% confidence interval. Let me just rub off the question so that we are going to have space to work with. So bringing everything together, um, S over, you already got this T, so S over roots. I think we solved that. Haven't we? Standard deviation over roots. Standard deviation was where is it? I've not even written standard deviation. I only wrote, okay, I've written it 262.23. So S over root n equals 262.23 divided by root of 25, and that is 5. So 262.23 divided by 5, yeah, around 50. Is that not around 50 something? So we have 52.446. 52.446. So the confidence interval, I think everything we need for the confidence interval now is complete. So we have what do you call it now? By x 513.32 minus 50, minus the t value 2.064 into brackets 52.446, then 513.32 plus 2.064 into brackets 52.446. Just let me manage that little space over there. So solving this, Mr. Man, we have 405.07 to 618.212. 618.212. Okay. So remember that these values are in thousands of naira. So to make our conclusion, we are just going to say that there is 95% confidence that the mean loss, okay, for all, because the question was for all robbery offenses. So we can, we have there's 95% confidence that the mean loss for all robbery offense is between 405 0.7 thousand to 608.212 thousand. Do you understand? Now we can just, since the values are in thousand, that's 000, so like 1, 2, and 3. So approximating to thousands, we have this would be 405, then 1, 2, 3, 070, okay, 0.00 681.123.212. I'm just trying to use standard form to just get my answer. So we have between 405,070 to 681 and 2. So we are 95% confident that the mean, the average loss due to robbery offenses or robbery incidents is between, for all, yeah, that's important. We are There is 95% confidence that the average loss for all robbery offense, or the average loss from all robbery offense, is between 405,070 then to it's 608 to 1,000. All right. So if you also want to calculate the ME, margin of error. So margin of error is analogous to what we did. I think some textbooks will just write it as E, right? So it's analogous to what we did. So it's going to be T alpha over 2, then the sample mean over root n. So I guess you can bear with me that this is going to, a question like this is a long question. I was going to like look for your standard deviation by yourself, and it's a long question. So and I think okay, I didn't even know that I did that. So we have 108.24, approximately 108.24. Okay, so that's in fact I think I am pretty much happy to like bring this series to to an end. So next is our assignment. So here we go. Assignment A. The data below shows a year's chicken consumption in pounds for 17 randomly selected people. Find the 90% confidence interval for the year's mean chicken consumption. Okay. Then B. Reattempt the question for 95% confidence interval. Then C. Calculate the margin of error and the standard error. Standard of error. Calculate the margin of error and the standard error for both confidence intervals and comment on your findings. So to quickly tell you, standard error ranges between 0 and 1. So if the standard error is 0, that's telling that your statistic is 100% your parameter, like no deviation at all. 100%. If your standard error is 1, just throw your data away. Just throw it away. It doesn't make any sense. It's too far away from what's your parameter. Your statistic will be too far away from what the parameter is. Then you have this data here. So it is measured in pounds. So somebody has 57 pounds of chicken in a year, 72 pounds, all of that, all of that, all of that. And then somebody adds zero. Ordinarily, I'd have just let you go and then you can solve this and I've done, I don't know, except you are really, really like, looking at it like, what's going on? So, because you're looking at those that are consuming chicken, so why should you include someone that does not consume chicken at all in your data set? Why? So, this is an outlier. So, I'm just trying to tell you now that zero is not going to be part of your analysis. You are removing it. Okay, if after what I said is still going to do something funny, then it's okay. But I'm just telling you now that what you are looking at is you are looking at people who consume chicken. Why did you come and put somebody that did not consume chicken inside your data set? Okay, so you should remove it as an outlier. Or if you don't, then that's fine. Okay, you submit your answer anyways, and we'll see what's going to happen. So that's that. The next series that we're doing is going to be on hypothesis testing. Yeah. Okay. Thank you very much. See you when I see you. Have fun.